Hi folks, we're now going to take a look at number 3 from the Unit 6 Quiz 2. So the question says that a quadratic function passes through these 3 points and we want to determine the equation. Okay, so remember that we have 3 choices here. We can either use standard, vertex, or factored form. So in any of these 3 cases, I'm going to have 3 unknowns that I'm going to have to solve for, and I have 3 points. Okay, so I definitely should have enough information. Okay, but if I can try to solve a system of equations that doesn't involve 3 equations and 3 unknowns, I'd be much happier with that. Okay, so I need to see if any of these points are special. Okay, and well, 0, 4 is a special point because when x equals 0, that gives us the y-intercept. Okay, and standard form in the equation contains the y-intercept. Okay, so had I been given information about one or more of the zeros, I would have used factored form. Had I been given some information about the vertex, I would have used vertex form. But because I'm given information about the y-intercept, I'm going to use standard form. Okay, because when x is equal to 0, these two terms disappear and I'm just left with c. So that's going to be my y-intercept. So I can right off the bat write that my equation will look like ax squared plus bx plus 4. Okay, so I was given right off one of my unknowns. Okay, but now I've got 2 unknowns left to find. So chances are I'm going to have to solve a system. Okay, so the way in which we can deal with this is take these 2 points, input them into the equation, and get 2 equations containing a and b. Okay, once I have that, I can solve my system. So let's start with negative 2, 18, and let's input that into the equation. So y is equal to 18, a times negative 2 squared plus b times negative 2 plus 4. Okay, but let's clean this up here. Let's try to make this as simple as possible. So I'm going to take this 4 to the other side. So 18 minus 4 is 14. And here, negative 2 squared is 4. Okay, minus 2b. So this is my first equation. Now I'm actually going to go a little further because they're all divisible by 2. So I might as well take it one step further and divide both sides by 2. So that's going to be 7 equals 2a minus b. Okay, so that's what I'm going to call equation 1. Okay, now I'm going to repeat for 313. Okay, so when y is equal to 13, let's replace x by 3. Okay, and now I'll do the same thing. Let me simplify. Okay, so let's bring the 4 to the other side. So 13 minus 4 is 9. And here we've got 9a plus 3b. Okay, and yet again, we can go one step further, divide both sides by 3. So we're left with 3 equals 3a plus b. And I'll call that equation 2. Okay, so here I could use either substitution or elimination. Okay, I would say elimination is almost always preferable, and it works out really nicely here because I have a negative b and a positive b. So I can just add these 2 equations together. So I'm going to do 1 plus 2. Okay, so let's start by adding the left side. 7 plus 3 is 10 equals 2a plus 3a is 5a, and negative b plus b is equal to 0. Okay, so I've eliminated this variable, and now I have something very simple to solve. Okay, so now 10 divided by 5 is 2. So now I just take one of these equations and use it to solve for the b value. So let's say I take equation 1. Okay, so 7 is equal to 2 times a, which I now know is, 2 times a, that's 2. Okay, and then minus b. So I'll bring the minus b to the other side, becomes positive b. Take the 7 to this side, so 4 minus 7, and so that's equal to negative 3. Okay, so now I have my a value, my b value, and I already had my c value from before. So the final answer is going to be 2x squared minus 3x plus 4. Okay, so just a quick recap. that when you're looking for an equation, okay, and you're given information, say uh, as points, okay, you want to see which points have a certain meaning with respect to the different forms of the equation. Because I had the y-intercept, it made sense to use standard form. If you have the x-intercepts, you would use factored form. And if you had information about the vertex, you would use vertex form. Okay? That's it for this one here.